Good afternoon to all. Any doubt in last class? No. Okay. Today we are going to starting new unit in first volume. That means unit 5. Listen. Motion of a system of particles and rigid bodies. This is new unit. Motion of system of particles and rigid bodies. Okay. Okay. Before going discuss about one very important concept. COM. Before going to discuss about this, we must know about basic concept. Okay, you know that very well. All the bodies made by atoms and molecules. You know that. Okay. At the same time, the force acting on the bulk body. Bulk, it is called rigid. That is classified into two types. First one is internal forces. Second one is external force. Internal force and the external force. This internal force acts among the particles inside the body. Clear? Then external force, the force acts on this body from outside. That is called external force. This is basic. Already you have studied. Okay. Then first we must know about what is a rigid body? Okay. What is rigid body? What is meant by rigid body? Any idea? Okay, listen. For example, when force acting on it, shape of this box changed. Clear? Okay. Or when external force acting on this table, like press this table, any changes in this table due to external force? No. But there is some little bit amount of deformation takes place in the wooden table also. But this deformation we cannot see because this is negligible. Okay. So in these two cases, chalk picks box, it is not an example for a rigid body, but a table, this is very good example for rigid body. So any idea? Yeah. A rigid body is a one which maintains its definite or fixed shape. Even external force acts on it. Clear? That means when external force acting on the body, suppose the shape of this body does not change, that type of bodies are called rigid bodies. Clear? So fixed shape or dimension does not change when external force acting on one of the body. That type of body, rigid body. Okay, but in practical life, there is no ideally rigid body. Okay, because I've already told you, when external force acting on it, little bit amount of deformation takes place. So in practical life, there is no ideally rigid body. But when considered rigid body, deformation is negligible. Okay, right. Then we are going to discuss about now important topic. I already told you. COM, center of mass. Okay, listen. Center of mass. Now we are going to discuss about center of mass, COM, of a body. That means of a rigid body. Okay, listen. Here, he's standing on boy. Okay, listen. This is cricket bat. Okay. Okay. Listen here properly. Okay. Yeah. Okay. What is this? Yeah, cricket bat. Example for rigid body. Okay. Listen. Center of mass here, rigid body. Listen here. Just consider one rigid body. For example, cricket bat. When rigid, keep in mind, when rigid body moves, all the particles presented in the rigid body need not take same path, but different particles takes different path depending upon types of motion. Okay, so here example for this, when rolls one wheel on the surface, the particles present in the wheel takes different path, not the same path. Keep it in mind. For example, here considered one cricket bat. Let us consider one cricket bat thrown in air with certain angle. This is angle, okay? Already you have studied about this in projectile motion. Remember or not? Yeah. When thrown this cricket bat in air, it is occurs, yeah, parabolic path. I am correct or not? This path, parabolic path. I am correct or not? Yeah. But all the points in this cricket bat takes parabolic path? No. Only one particular point takes parabolic path. Other points in this cricket bat, no, already told you, no need. Acquire same path. I am correct or not? Yeah. Here only one particle or one point in this cricket bat takes parabolic path. that particular point called as center of mass of this rigid body. Okay? So, what will be the definition for center of mass? Come on, tell me yourself. From this idea, already you studied about center of gravity in 10th standard, remember or not? Yeah. Come on, yourself. Yes, very good. Because center of mass of a rigid body is defined as a point where entire mass of rigid body appears to be concentrated. That's all. Clear? So, entire mass of the rigid body concentrated at single point. Only one point. That point called as center of mass. COM. Okay? So, after understanding center of mass in this unit, fifth unit, compulsory 4 mark in your pocket from it. Keep in mind. Okay? Then, for regular shape bodies, for example, and for regular shape bodies and uniformly mass distribution bodies, that is important. Center of mass will be, for example, regular bodies, circle and sphere. This is a regular shape bodies. At the same time, uniform mass distribution will be there. For this type of bodies, center of mass will be its geometric center. For circle, inside. At the same time, for sphere, its geometric center. And other types, that means other regular bodies. For example, square, rectangle, cube, cuboid. For this rigid bodies, that means regular bodies, regular shape bodies, center of mass will be, for example, square, center of mass could be the point where meets diagonals of the squares. That's all. Okay. At the same time, one very, very important point, center of mass will be inside or outside the body. There are two options. You can understand hereafter, that means when coming one half of the unit. No problem. Okay. Now, we are going to discuss about next one. Listen here. Center of mass. What? Center of mass for. Center of mass for. Listen. Center of mass for distributed point masses. Center of mass, COM, for distributed point masses. That is important. Distributed point masses. Okay. Before going to discuss about this, we must know about what is point mass. What is point mass? Point mass means, point mass is a point particle, not point particle, hypothetical point particle. What is hypothetical? Assumption. Considered. So, point mass is a hypothetical point particle which has non-zero mass. Which has non-zero mass. And no size or shape. No size or shape. Okay, it is called a point mass. Okay, come on here. Now we are going to discuss about center of mass for distributed point masses. Listen. Distributed point masses. This is mass M1. Mass M2. M3 mass M3. This is mass M4. But this is RCM vector is equal to XCM, YCM and ZCM. Okay, listen here. This is X axis, Y axis, Z axis. Yeah. Clear? No. Creates some confusion to you. Am I correct or not? Yeah. Leave it, no problem. Listen first. Here let us consider n particles. How many particles? How many particles? Don't know. N particles. That means n masses. From M1, M2 up to Mn. So that is called n particles. Listen properly here, because of very important this, compulsory one question will be there from need 4 mark in your packet. So listen properly. To find out center of mass of a collection of n particles, first you choose coordinates x, y and z. X coordinate, y coordinate and z coordinate. Okay, that is very important. Here M1, M2, 4 particles are considered. This is position vector of center of mass of this system. Okay, listen. This is confusion. Okay, no, leave it, no problem. Listen. Now, here to understanding easily, to find out center of mass of one of the system, here already told you consider compulsory coordinates. I am correct or not? Yeah. This is 3 coordinates. This is position vector of the center of mass of this system. You cannot understand. Okay, leave it, no problem. First, listen. To understanding very easily, to find out center of mass of the system, first listen. In only x coordinate. Listen. Here, mass M1. Mass M1 in x coordinate at a distance x1 from the, this is origin, from the origin. This is position of the particle M2 along x coordinate at a distance x2 from the origin. And consider this is mass M3 at a distance x3. Okay? So, center of mass of this system in x coordinate, we can written as, listen properly here, center of mass in x coordinate or of x coordinate, xcm, it is equal to, how many particles are there? Yeah, 3 particles or maybe n particles, no problem. Summation mi xi by summation mi. This is the equation or formula for to find out center of mass of x coordinate. Simplest formula. Okay, or xcm is equal to summation. Am I correct or not? Total. Am I correct or not? For this system, how many particles are there? Yeah, 3 particles at 3 different distance. Okay, so from this you can written as R. Before that, XCM is equal to summation Mi Xi by here. Summation of Mi means here total mass of the particle. Okay, so instead of summation Mi, it is equal to cap, you can written as caps M. That means the total mass of the particles, all particles. That's all. That's all, very simple. Or in another method, another form, XCM is equal to summation, no? How many particles? 3 particles, no? Therefore, this is a problem here. M1 x1 plus M2 x2 plus M3 x3 by M1 plus M2 plus M3. That's all. Very important formula. Clear? Suppose here only 2 particles. Yeah, here comes M1 x1 plus M2 x2 by M1 plus M2. That's all. Clear? Simplest formula. Okay, next. Similarly, center of mass of y coordinate. Yeah, from this summation Mi, yeah, Ya by M. That's all. That's all. Okay. Similarly, center of mass of z coordinate is equal to summation Mi Zi by caption. Okay, that's all. So in general, in general, you can written as, yeah, come on, here, RCM vector is equal to XCM I cap, YCM J cap, ZCM K cap. What is this? Yeah, listen here. RCA, where RCA vector means position of center of mass or position vector of center of mass of this system. Now, understand? Yeah, that's all. Position vector of center of mass of this system. How many coordinates are that? 3 coordinates. So, RCM is equal to, we can written as XCM I plus YCM J cap plus ZCM K cap. IJK, you know that very well, unit vectors along X, Y, Z axis. Okay, and here, before that, we can write as one formula with the help of this. RCM vector is equal to summation Mi Ri vector by M. From this formulas. Okay, what is meant by, already told you what is meant by RCM? Yeah, position vector of center of mass of the system. Position vector of the center of mass. Basic formula. Summation Mi Ri vector by M. Okay, RCM, okay, told you already. What is Ri vector? What is Ri vector? Yeah, Xi I cap yi j cap plus zi k cap. All caps will no problem. Consider similarly same or y, no problem, caps y. Okay. So RC vector is the position vector of center of mass. Position vector of center of mass. But RI vector, position vector of RI vector, position vector of distribution of masses. Position vector of center of mass. RI vector, position vector of distribution of point masses. Clear? Try to understanding the difference between RCM vector and RI vector. Okay? Here ijk, I cap, j cap and k cap unit vectors along z axis and y and x axis through y and z axis. Unit vectors. Clear? At the same time, come here. XCM is a general formula, no? Yeah. From this, we can written as the famous formula for RCM vector also. Come on, listen. RCM vector is equal to M1 R1 vector plus M2 R2 vector plus M3 R3 vector also, no problem, by M1 plus M2, that's all. Okay, this formula, this one, come on here, and this. Two formulas are very important. Keep it in mind. Clear? Come on, see it again, once again. Any doubt? Come on, see here, fully. This formula and the XCM formula, they are very important formulas to solving the given problems in your theory exam or NEET exam. Clear? Shall we move to next one? Okay. Okay, listen. Theory okay? Understand? Yeah. Two bodies of masses 1 kg and 3 kg. So this is, let us consider M1 and M2. Okay. Have position vector, already told you. RI vector. Remember? I cap plus 2j cap plus k cap and R2. 3i cap minus 2j cap plus k cap. Okay? So just consider this is R1 vector, this is R2 vector, okay? Respectively. The center of mass of this system as a position vector, already told you about RCM, remember or not? Yeah. Come on, tell me formula yourself. Don't know. Okay. You? RCM is equal to, yeah, very good. RCM vector is equal to, yes, M1 R1 vector plus, yes, M2 R2 vector plus M3 R3 vector. No need, very good. What is the reason? Yes, only two masses, enough. So M1 plus M2, that's all. After substituting the values directly in this formula, now we get answer. Look here, three options are given. Come on, try yourself. Come on, fast. Because already you have studied about position vector and unit vectors also. Am I correct or not? Yeah. Try yourself. Take few minutes. Quick. Yes. First option? No. Second? Third one? No. You are wrong. You? Yeah, very good. Second option. Yes. This is correct. How, sir? Come on, listen. Listen here. Center of mass. Sorry. Position vector of center of mass of the system. Listen here. M1. What is M1 value? 1. Okay. Of R1. Yeah. I cap plus 2 j cap plus k cap. Okay. Plus M2. Yeah. 3 of R2 vector. No. Yeah. Minus 3 I cap minus 2 j cap plus k cap. Very good. Multiplying 1 no, therefore I cap plus 2 j cap plus k cap. Yeah. I wonder that. Yes. 3 3s are minus 9 I cap plus and minus 6 j cap plus 3 k cap. Okay. So yeah, directly you can add I here. I know, so minus plus, so minus 8 I cap here, j cap plus 2 minus 6, so minus 4 j cap. At the same time here done one mistake, whole divided by, that is important. Am I correct or not? Yeah. M1 plus M2, how much? 1 plus 3, yeah. 4. So whole divided by 4. Clear? So, okay. 4j, okay. Here, k, okay. Plus, okay. So, plus 4 k cap by, okay. That's all. Yeah, now you can divide it directly. Minus 2, very good. I cap minus, yeah, 1 j cap here plus, no, so plus 4 cancel, so 1 k cap. So minus 2 I cap minus 1 j cap plus 1 k cap. Yeah, what is the answer? Option is very good. Second option. Clear? Need out? Simplest problem, no? Already told you a lot of times. After understanding about center of mass, 4 marks in the target. Okay? Thank you.